In this experiment, we are going to find out that uniform circular motion occurs when an object travels around the circular path at a constant speed, but with continuously changing direction. As you can see, we use one turntable, and also as you can see, we use ropes. We use ping pong balls with 258 gram, an eraser with 9.73 gram, an orange ping pong ball with 1.95 gram, 20.73 gram squash ball, and also our biggest mass is almost 111 gram big ball. After clearly determining the tools, I tied the rope to the turntable, then I started to rotate the turntable, as you can see, with some certain velocity. The rope has a certain length which we calculated at first. With the known velocity and the known length of the rope, it is possible to calculate the centripetal force. While I'm doing this experiment, centripetal force increases as the radius increases. So when the radius of rotation was increased, a larger hanging mass was required to maintain equilibrium. I show the video in slow motion so that you can see it more easily. Whenever the black line you see on the turntable, you can see it right now, appears, we understand that it had made a turn. The number of seconds in which this tour takes place gives us information about the period. And then when we calculate the period, all that remains is to know the size of the weight we tied to the rope and the length of the rope. For example, this mechanism rotates 13 times in approximately 13 seconds. The weight of the orange ping pong ball is 1.95 grams and the length of the rope is 30 centimeters. With this information, we can find the centripetal force. To find more data, we repeat this experiment with different rope lengths and different weights. We calculate the period again and find the velocity. Let's not forget that speed, mass, and rope length are important factors for us to find the centripetal force. As a conclusion, let's talk about the aim of this study. The study was to investigate how centripetal force depends on radius and angular velocity for an object in uniform circular motion. To improve practical skills in managing experimental uncertainties and identifying possible sources of error in the experiment was also a part of this study. The main idea of my experiment is to investigate and verify how the centripetal force to keep an object in uniform circular motion. By using a rotating mass connected to a hanging weight, this experiment demonstrates that the force needed for circular motion increases directly with radius and increases according to the square of angular velocity.